I don't know. I have no idea what the hell to do to start a video. So if you think something is like silly or stupid, I don't know. What am I supposed to do? What the hell am I supposed to do to start a video? Where's the bell? How come a bell doesn't ring? Anyways, it's good to see you. Today we're going to practice linear and quadratic systems of equations, which sounds harder than it is or more difficult than it is. So if you're at the dinner table, you can tell mom and dad or whatever, say, hey, today I learned to solve a system of linear and quadratic equations. They'd be like, damn, they don't need to know you already knew how to do it. I'm going to show you already know how to do it. By the way, before we begin, quick question. What's your bright spot today? My bright spot is a little Easter egg I got in this video. So I ain't gonna let you ain't gonna know till the end. I'll let you know at the end. All right, so let's go get it. The reason I said you already know how to solve these equations is because what we do in a system, by the way, a system of equations, right? We got two equations, two unknowns. You can't solve a single equation with two unknowns in it, but you can sure as hell solve two equations with two unknowns. And we're going to use the elimination method, which I'm hoping you already have learned from linear equations. So all we're going to do here is eliminate one of the variables by adding or subtracting. And because this variable is squared and also linear, we're just pretty much going to be eliminating those y's. So let's just go get it. What I'm going to do right off the top is I'm just going to subtract the bottom equation from the top equation. Because remember, the left side equals the same damn thing that the right side does. So here I could do y minus y, and that's 0, because subtracting y is the same as subtracting 4x plus 10, because they're equal to each other. So on this side, I'm going to subtract the 4x plus 10. So that's x squared minus nothing. There's no squared term here, so it's still just x squared. Now I got minus 2x, and I'm going to take away 4x's. So here's where you could make, computational errors with, subtracting negatives and positives incorrectly. But we got negative 2x minus a positive is going to bring you minus 6x. Because remember, when you subtract positive, you get more negative. When you take away positives, you get closer to 0 or you get more negative, depending if you start above or below 0. So here we go. Negative 6. I'm going to take away a positive, so I'm going to get more negative. Cool. So this is just the quadratic. What the hell? Okay, sorry. That almost upset my Easter egg. You can solve it any of the ways we know how to solve. Because these are pretty much going to be set up for x to have integer values, I'm going to start by trying to factor these. So that's how I'm going to try to solve them. So I'm going to factor this. That gives me x minus 8 times x plus 2. Now I'm going to take advantage of the structure of intercept form, for those of you who like that, or the zero product property, and realize that here, this x has to be 8, because 8 minus 8 is 0, and 0 times 10 is 0. So one answer that works is 8. And the other answer that works is negative 2, right? And that's where some of you students say, I take the opposite. And that's fine, as long as you realize that the reason you're taking the opposite is because that's how you get to 0. That's how you get to 0. That's how you get to 0 from here. That's how you get to 0. Negative 2 plus 2 is 0. 0 times negative 10 is 0. All right, so we got our two values of x. Now we got two solutions, but there's two variables. There's an x and a y. So right now, I wish I had more marker colors. Over here, this is what I know so far. I'm going to put my two answers. I've got 8 for sure and negative 2. But I got to find that y value. So let's do that now. I'm just going to come to here and insert the 8. So I'll put the 8 here and wait, that's going to get me 0. That's how, oh, yeah, obviously, sorry. Started to make a little mistake there. This damn being human thing, right? It's rough. It's rough. Why the hell was I putting the 8? The 8 makes this, that's true, but I'm going to plug it back into this equation. I need to plug it back into one of these two equations, right? Because that's ultimately the ones I'm trying to find the solution for. So I'm going to go to the linear equation because I think it's just easier to work with than the quadratic. So I'm going to, so 4, this is what I was trying to do. I'm going to just write it twice because I have to do it twice, okay? And hope I'm not off the white. No, I think I should be good there. All right, so here's where you plug in the 8 and you plug in the -2. You can also do it to here. You're going to get the same answer because that's part of the solution to a system of equations. I mean, at the end of the day, I'm not going to graph these like perfectly, but you have a parabola, right? And you have a line that has a positive slope. And so there's two places that it's going to intersect. Well, one of them is going to be here at -2, and the other one's going to be at 8. So when it's at 8, we got 32 plus 10, which is 42. So 842. And now here, we got y is equal to -8 plus 10, which is 2. So this is 2. Those are two solutions. These would be these two intersection points where when you put x equals the -2, both equations are going to equal 2. If you make x equal to 8, both equations are going to equal 42. I told you knew how to do it already. You didn't believe me. Or maybe you did. I don't know. Maybe I shouldn't be so presumptuous. Let's try another one. All right, let's go get it. All right, let's, you know what I want you to do? It ain't a mystery what I'm about to say. I'm going to say pause that damn thing and try it on your own. Pause. Unpause. All right, let's get it. So again, it's a system of equations, but you already know how to solve it. You already know how to solve it because you can solve a single quadratic equation, and all we're really going to do is just eliminate the y by adding or subtracting, but in this case, they've both been subtraction. So here we go, y minus y is 0, all good in the hood. Okay, so these two are equal, so I can, on the right side of the equation, I can subtract 2x plus 1, so x squared minus, there is no squared value. 2x minus 2x. Oh, that's interesting. That's 0x. Interesting. Oh, I shall write 0. I'm going to write 0x this time, just for now. All right, -3 minus 1 is -4. All right, I like this one. Let's see. So we have 0 is equal to x squared minus 4. A lot of my students, they would find this to be difficult because, you know, they like it to be in standard form. Like they want to see a squared, and then they want to see the x term with a number in front of it, right? So this feels different in a way. But we know what we're doing here. We're just solving an equation. So what I'm going to do is you could factor this, by the way, right? Because, you know, it is going to be x minus 2, x plus 2, right? Because that's a difference of squares. And so you're going to have your values are going to be 2 and -2. But what I'm going to do instead is just, since there's only one unknown, which is x, I don't have two of them, right? I'm just going to move that 4 over. So however you solve, it's good. And then square root both sides. 2 and -2 is equal to x, right? By square rooting both sides. I'm always torn on these videos because there's a lot of ways you can do mathematics. I'm always thinking to myself, like, man, should I show like every single way? But then the video's too long and la da 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 da. A lot of you probably like, well, the video wouldn't be so damn long if you would just keep working the problem. Okay, I'll do it this time. I promise. I promise. All right, so there we go. We got our x values. We know we've got a parabola and a line, and they're intersecting in two places. So we just got to see where. So I'm going to go back and choose, let me erase this. All right, well, let's plug in our x values and see what our corresponding y values are going to be. So we got 4 plus 1 is 5. Negative 4 plus 1 is negative 3. Gorgeous, 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 gorgeous. And those are two solutions. Fundamentally, we got a parabola, we've got a straight line with a positive slope, and they're intersecting in two places. All right, that would be 2, 5, negative 2, negative 3. All right, well, should we get one more? I think we should. I'm going to try to twist it a little bit for you, so stay with me. We're almost there. Okay. So why don't you try this one on your own? Hit that pause button. Pause. Drop a marker. Unpause. Let's go get it. Okay, so this one's different because the bottom, that linear equation, is in standard form, not slope-intercept form. And the top one's in kind of a crazy form too, right? I hasten to call it standard form, but it's got all its variables on the left side, and it's got what they're equal to when you combine them all on the right side. Okay, so, but fundamentally, we're still subtracting. So not a lot has changed. I'm still looking at this, and I'm seeing, I'm not going to eliminate that variable because I don't have an x squared to subtract or add. So I'm not even going to bother with this x. If I can't get rid of the x squared, I'm not going to worry about getting rid of the x. And I see I got y's top and bottom. The sign is the same. They're both positive. And so I know if I subtract the bottom equation from the top equation, the y's are going to eliminate themselves. And I can do that because the right side is equal to the left side. So as long as I subtract 1 from the right, I'm allowed to subtract negative 3x plus y from the, say it after me, left. Okay, well, let's go get it. Okay, negative x squared minus, there's no squared term again. Good. Okay, minus 9x minus 3x. So here's that minus a negative. Here's where you are taking away negatives. When you take away negativity, your life gets more positive. God bless you. Let's do it. May all of our lives get more positive, always, right? That's a nice goal, I suppose. There we go, minus 6x. Here we go, boom, boom, boom. There's your 0. There's the elimination of the y. There's the 0y. 6 minus 1 is 5. All right. So one thing I'm going to do here is I look at this. I do not like my a value, right? That value to be negative. I just don't like it. I just don't like it. So I'm going to multiply everything by negative 1. Or you could say divide by negative 1, but I'm going to change that sign right now so it's x squared plus 6x. That's the beautiful thing, right? One of the many beautiful things about math. You can play around with its form, make it a little bit more pleasing to you. I'm going to anticipate things being factorable, so I'm going to go plus 5 is equal to 0. Gorgeous, right? I could factor that, so I'm going to go x plus 5, x plus 1 is equal to 0. I'm feeling good. I'm feeling like we're almost there. Grab that red pen. I think I might be near the bottom, so I'll go that direction. This means that x has to be negative 5, right? So negative 5 is going to create that 0. This 0 is going to be created by negative 1. Some of y'all are saying take the opposite because that's how we get to 0. It's how we get to 0. It's how we get to 0 from here. All right, so I'm going negative 5. There it is. Going negative 1, comma. Got to figure out my y values. So just going to erase this work real quick. All right, well, here we go. Let's see, what's y gonna, now, you know, this is a little bit more difficult because y isn't all by itself, so there's gonna be a little additional step, but nothing I think we're too concerned about. There we go. Let's lastly subtract 15 from both sides, so we get y is equal to negative 14. right? That's going to be up here, right? So then negative 14. And then lastly, a negative 3 times negative 1 is positive. All right, subtract 3. And now we feeling good again. All right. Gorgeous, 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 gorgeous. All right, well, hey, remember I said my bright spot was the Easter egg? I think you called it an Easter egg, right? The Easter egg in this video is my shirt. My shirt. It says stay hip and be kind. Now I don't do it in every video because I kind of forget, but I do it in every in-person class. I always tell the class the last thing I say every day is stay hip and be kind to each other. So I guess my nephew, I must have told him that because my nephew made this. This is like an original shirt. Pretty cool, huh? Original art. So I won't forget today. My last message to you is to stay hip and be kind to each other.